Welcome everyone. Hope you all having a good night. And today we'll just be talking about some of the amazing women that in astronomy that kind of laid forth the what we now our current understanding of astronomy, and some that came after them as well. Starting off with the late 1800s, Harvard was a male world. Women were not allowed, mainly. And even though at the time, like in the mid 1800s, the six of the seven sister colleges, they had already opened, and so there were women that were starting to slowly be educated. However, these colleges did not have the same quality equipment or the resources and funding that male colleges did. So they were competing against that, but women were slowly starting to get educated. And at this time, women did not have rights, and it was no different for the field of astronomy. They weren't allowed to go use telescopes at all. Part of the reason was probably because of this book on the left called A Fair Chance for Girls. Kind of deceiving. When I first saw this, I was just like, oh, awesome. Like someone was advocating for women rights at the time. That's actually not what it was doing. It capitalized this idea that women should not do anything it should not focus on higher education, and that doing anything exhaustive would possibly harm their reproductive organs. So it might be possible that for this reason it was a very popular idea at the time. That also contributed to why women couldn't use telescopes. They believed that it was a very difficult job, and staying up all night could possibly harm the reproductive organs of women. So they were not allowed, and for a very long time they were not allowed to use telescopes. At the same time, in the mid 1880s, around 1885, this new technology was created, and was starting to be up and coming, right? If you're familiar with astrophotography, it's this idea where you take a picture and you get a longer exposure time using your telescope, and you can see more stars. Well, at the time, there's glass plate technology was first coming out. And on the right, you see one of these glass plate images, and all those black spots are stars in the sky. So at the time, in mid 1880s, Dr. Edward Pickering became the director of the Harvard College Observatory in 1887, and he had this idea of mapping the sky using these glass plates. He thought, and he genuinely believed and advocated that by all the male astronomers looking at the telescope, that the human eye could miss something, and it was just exhausting for your eye, and that by using these plates we would be able to discover a lot more and see the differences over time. However, it was a lot of tedious work, and he did not have enough manpower to get this done. And he believed that it was a task so easy that he could just train anyone. He even was quoted for saying that even his maid could do this kind of work. And that's exactly what he did. He hired his maid, and there was a group of women working at the Harvard College Observatory during this time period, starting around 1877, when Pickering became director. And they were referred to at the time as Pickering's harem. It's a derogative term, and it was kind of meant to show that the male were superior to these women, and these women's jobs were just to look at these images and these plates. These pictures here are courtesy from a Cosmos episode. If you're a fan of Cosmos, there's season 1, episode 8 does cover some of this. It's a really cool, good episode. And you can see here that the men are kind of just looking into this room, and that's where they belonged. They weren't allowed in the telescope, and they were only allowed to look at the cosmos through these glass plates. And these are some more pictures of some of the women. So that was a derogatory term given to them, but they are known as the Harvard Observatory Computers. If you've watched the movie Hidden Figures, and if you have not, it's on Disney Plus. I highly recommend you check it out. It's a really good movie, one of my favorites. And if you've watched it before, you're probably familiar of women being used as computers, where they in the 1950s, NASA had hired women computers to do all the calculations for the Apollo mission. Well, in the field of astronomy, the same thing actually happened as well, with Edward Pickering at the Harvard College Observatory. So these are pictures of the women computers in the late 1800s, early 1900s, and in the room where they would just constantly look at those glass plate glass plates and try to learn more about the stars. They were usually typically hired for a specific task, but Edward Pickering did allow them to do their own work on their spare time. And today I kind of wanted to focus on three of them that made some really amazing breakthroughs and discoveries that's really impressive, given the fact that they did so just by looking at all these like spots and on this glass plate. And whenever they did find some kind of discovering, the findings was published under Pickering's name and not the woman who discovered it. Unfortunately, that is how it was at the time. So some of these the two of the main discoveries that I'll be talking next about, they were published under Pickering's name with only a sentence that said it was from the work of whichever woman had done the work. So the first woman I wanted to introduce you all to is Williamina Fleming, and she was one of the first ones that Pickering hired for the woman computers. As I mentioned, he had said that the work was so easy that a maid could do it, so he hired his own maid, and Williamina Fleming, sorry, apologies about that, was one of the first ones. She cataloged over 10,000 stars. So literally just by looking at all those images, she cataloged those 10,000 stars, and she ended up discovering 10 different nova, 59 gaseous nebulae, and over 300 variable stars. On the bottom right, you can see a picture of that's the horseshoe, the Horsehead Nebula. If you were into astrophotography, it's a very famous nebula, and she was the first one to discover it. Another reason why she's significant is that in 1898, she was appointed the observatory's curator of the photographs, and that marked the first ever woman to hold the title at Harvard University. And as with that position, she was responsible for hiring more women computers and for managing all of those plates. At the time, it's estimated that she examined about 200,000 of those plates. The entire collection that Harvard has is about around 500,000 or 500,000 plates. So she did examine a lot of them. And also want to mention that these plates still do exist, and Harvard actually is currently has a project in where they're trying to preserve these, as well as the logs where all the women wrote down all their findings, notes, results, and they're currently in the process of trying to match all the logs to the plates themselves, which I thought was pretty cool. Moving on. The next woman that I'd like to tell you all about is Annie Jump Cannon. So as I mentioned, their responsibility was to look at these glass plates of images that were taken of stars, and so sometimes it was just like actual pictures, right? Other times it was spectra, right? So right here, that's what Annie did. She looked at spectra. So for any non-astronomers, non-science background that are in the audience right now, I kind of wanted to explain that a little bit. If you're not familiar with it, it is still how astronomers typically do learn about stars. So if you put a prism in front of a telescope, you will break the light into its color components. Kind of like here in this picture. If you were around during the time of like CDs and you were ever like a kid and would like look at CDs in the middle, you see that light gets diffracted or split into its colors as well. A fun test you can do at home. So that's the idea with collecting spectra. You put some kind of prism or mechanism that will break up all the light into its color, and from there you can then see what these stars are made out of, and that has more to do with atomic physics and how you get these lines here in the spectra. So what Annie did was that she analyzed all those pictures and saw the spectra of the different stars, and she created her own classification system. And so by looking at these patterns, she found that all stars kind of followed this pattern that was broken up into seven categories, and within those 7 categories there was 7 subcategories. And she looked at all of these images, and she classified spectra for over 230,000 stars. So you can imagine she literally memorized her own system and logged all of them, and this classification is actually still used today. It is known as the Harvard Classification of Stellar Systems. And if you've ever taken like a general astronomy course, you've probably learned of it before. And you've probably learned of the mnemonic, "Oh, be a fine girl, guy, kiss me." Annie Cannon herself actually created that as well, to try to make it easier for others to remember her classification system. So the next woman that and also briefly to mention about Annie Cannon, I wanted to add that she lost her hearing when she was younger. So she was deaf, and all this work was done while she was deaf, and same with Henrietta Swan Leavitt. Just wanted to highlight everything that I learned about these women, because it truly is amazing how much they were able to accomplish at the time. So Henrietta Swan Leavitt, her task given by Pickering was to look for variable stars. So variable stars are any kind of stars that their brightness varies over time. And so she was supposed to, because these images were taken at different time frames, she was supposed to see if she could find any variations. And she would just place the plates on top of each other and look for changes in brightness. She mainly looked at the Magellanic Cloud, which is a dwarf galaxy of the Milky Way galaxy, but at the time it was not known yet that there was other galaxies. It was believed, and that's why a lot of different astronomical objects have the term, are called nebulae. It's because prior they didn't know that there was other galaxies, and they believed that they were just gas clouds. So while she was looking at that cloud, she found a specific type of variable star called a Cepheid variable. And basically these kind of variable stars, they change their brightness over the course of, like, whether it be hours, days, months. And she realized something really important about this type of star. She realized that how their pulsation of how they changed in brightness was related to how intrinsically, or how bright they really were. So by how bright they really were, by that I mean, if you think about the fact that the sun is really, during the day, the sun makes the sky really bright, right? That's because of how close it is to us. So stars that appear bright sometimes aren't actually brighter than a star that looks dimmer. It's just that the dimmer one is further away. So with her realizing this, she found a way for these type of stars, she could find out how truly bright they were, regardless of like how far or close away they were. And this was really important and a major breakthrough in the way that astronomers were able to determine distances in the universe. And it's still a way that astronomers use to determine distances to this day. And the way that before, the relationship she just discovered was often called the period luminosity relationship. That's actually the way I learned the relationship. However, it is more recently starting to be referred to as the Leavitt law, and she is being given more credit for it now. And it was very crucial at the time, just because it gave kind of astronomers almost like a yardstick, but in reality it was like a standard candle, what we refer to as standard candles. And that just means that we now know the actual brightness of a star, and by knowing the actual brightness of a star, we can find distances, and you have them all across the universe. And so she ended up finding around 2,400 variable stars, and her legacy was actually that it was really important. Her work was really important for what would later become Hubble's work. If you've heard of Edwin Hubble, he was the one who discovered that M31, also known as Andromeda, is actually a galaxy, and that it was moving away from us, and hence that the universe is expanding. So he was the first one. He was the one to discover, and he's very famous. He was only able to do this by using Leavitt's technique of measuring distances. Without her, it would not have been possible. And additionally, wanted to mention that in 1921, she died from cancer, which was 4 years before she was able to be nominated for the Nobel Prize. She was nominated for the Nobel Prize in 25, but unfortunately had to be retracted because she was no longer alive at the time. Okay, so those were the three of the women from the Harvard computers that made some really big discoveries, or one of them was the first woman woman hired at Harvard University. There was actually about a few dozen that Pickard hiring during his time there at the observatory. Over the course of like 40 years, it's said that it's constantly quoted to be either between like 40 to 80 women, and those were just 3 of them. And how I said, one of them was the first woman hired at Harvard. The second one, she created a classification system of stars that we still use today. And the last one, she she discovered Cepheid variable stars, which gave astronomers a standard candle and actually helped astronomers determine how far away stars were from us. So now moving on to some other astronomers, the next woman astronomer I wanted to tell you all about is Cecilia Payne-Gaposchkin. So she was actually in England in 1923, and during that time, women were still forbidden to get an advanced degree in science in England, and she had gone to a lecture in England by Sir Eddington, who was the first to provide evidence for Einstein's theory of general relativity, and she felt so inspired that she immigrated to America and said that nothing would stop her from pursuing the field of astronomy, and she ended up using Cannon's data, as I mentioned before. Cannon had created the stellar classification system of 7 different, with 7 main categories, right? And so it was Cecilia who actually realized that this classification system was based off of how hot or cold the temperatures, the stars were. What she did was that she used Saha's equations, and her expertise in atomic physics to determine the spectra that should be produced based on temperatures, and realized that it corresponded directly to what Cannon had determined. And therefore that classification system I mentioned also tells you the temperature of stars, the ranges of temperatures in stars. By using this data, though, she was also able to discover the composition of the stars and what they were made out of. In astronomy, anything heavier than helium we refer to as a metal. So hydrogen, helium, and then everything heavier than helium is a metal, right? So at this time, when Cecilia Payne was at Harvard, the current belief was that the stars were made of the same things that Earth were. They believed that stars were made mainly out of metals. And by analyzing Cannon's data, Cecilia realized that stars were mainly made out of hydrogen and helium, and because stars make up the majority of the universe, that means that the majority of the universe is also made of hydrogen and helium. So that was her discovery, and it was a breakthrough in astronomy. However, and kind of leads us to current astrophysics. However, she was highly discouraged by Russell. If you're an astronomer and have heard or have taken a general astronomy class, you've probably heard of the Hertzsprung-Russell diagram, which tells you about trends in the lifetime of stars. But Russell was a strong proponent for the fact that stars were composed of the same elements as Earth. So when he read Cecilia's dissertation, he felt sorry for her, and he wrote her letters saying that he felt really bad for her to believe this. And she actually ended up adding some comment to her thesis that kind of took away from how important her discovery was. 4 years later, though, Russell realized she was right, and the good thing is he did give her credit for it. And it was at the time, there was a lot of well-known astronomers have given her credit for it being the most brilliant thesis in astronomy, since it really laid the foundation for our understanding of the contents of the universe. Another big thing is that she was the first person to earn a PhD in astronomy from Harvard. However, it wasn't actually officially from Harvard. It was given to her by Radcliffe College, which is the sister institution of Harvard, just because women were not allowed to have degrees yet from Harvard. And in 1956, she became the first woman professor at Harvard, and then later would become the first female chair of the Harvard Astronomy Department as well. And she consistently was an advocate for equal woman rights while she in the field. Okay, So the next woman astronomer that I would like to tell you all about is Jocelyn Bell, formerly Bell, now Burnell. Her discovery was that she discovered the first four pulsars while she was helping build a telescope for her thesis, for her PhD thesis, a radio telescope. She noticed some anomaly, right, that was coming from the same area of the sky. So she knew that it had to be coming from the stars because it was fixed in the sky. And if you, just a quick description of what a pulsar is that it is a neutron star. A neutron star is the remnant of a star. It's no longer alive, so it's a dead star, meaning it's no longer fusing any elements in its core. So our sun fuses hydrogen to helium, so neutron stars don't have any fusion going on in its core anymore. And instead, it's decreased in size so much, and it's so small that it's being held together by a quantum mechanical effect called neutron degeneracy pressure. And it is about 1.4 masses of our sun within a 20-kilometer diameter. So typically it's quoted that these stars are about the size of a city, 20 kilometers, but are 1.4 solar masses. So if you were to take a teaspoon of it, the density would be it'd be very, very dense, meaning it's just very massive for a very small space. Anyways, continuing on to pulsars. So a pulsar is a type of neutron star, and it has these very strong magnetic fields and it's rotating very rapidly. But the magnetic field and its rotation axis are not aligned. So what ends up happening is that it shoots out these like beams towards us along the line of sight, and it's kind of like often in a common analogy is like a lighthouse. Right? So this is Jocelyn's discovery. She discovered this at first. However, it did take her a lot of convincing to her advisor, who is Hewish, Anthony Hewish. She had to convince him because he was very skeptical and first believed that it had to be some kind of man-made source, although she was very persistent in her discovery. And two more other things I wanted to mention about her is that later in 1974, Anthony Hewish received half of the Nobel Prize in physics for his decisive role in discovery of pulsars, and Jocelyn was not given any credit. There was a lot of prominent astronomers at the time who argued that she should have been credited, although she wasn't. And she 3 years later came out with a comment, and she took it very well, and she said that the success and failure of a project always lies on the advisor of the project. So she believed that it made sense for her advisor to reap the benefits. Later in 2018, she was awarded the Special Breakthrough Prize in Fundamental Astronomy, and this award comes with a $3 million prize, and she donated all that money to help fund female, minority, and refugee students to become physics researchers. And this is called the Bell Burnell Graduate Scholarship Fund, and it's being administered by the Institute of Physics in the UK. So that's pretty cool as well. And next, I would like to tell you all about Vera C. Rubin. So if you've all heard of dark matter, maybe you've heard of dark matter, you probably don't know what it is. No one does. We're currently still trying to figure that out in astronomy, and it's believed it's some kind of particle that doesn't interact with light, and probably interacts only through the weak force. So if you are an astronomer, you may have heard how this was discovered. So how this was discovered, and I've heard of it as the galaxy rotation problem before, but I had never heard that it was discovered by Vera C. Rubin. She's a woman astronomer, and she actually was discovered. So the idea is that if you have a galaxy, right? On the right, if you have a galaxy that's rotating, you can measure the rotation speeds, and using our understanding of gravity and how much light we see, you can determine how fast the outside should be rotating, right? So what ended up happening is that, and this is the galaxy rotation problem, is that based on the amount of light we see, the outside should be rotating much slower. So the outside of this galaxies are rotating much faster than it is predicted by our understanding of gravity. So then that means there's some kind of matter that we don't see, some like invisible matter that doesn't interact with light, and that is what we refer to as dark matter. And that was, so the evidence of dark matter was discovered by Vera C. Rubin. She was actually the first woman to be allowed to use the Palomar Observatory in San Diego. Before that, women would women were not allowed to use telescopes. It wasn't until I believe like the 1970s that they were actually allowed to. And she was the first woman to. And prior to that, they'd usually like sneak in with their husband's name or try some other way to sneak in, even though they were already receiving an education in the field. And there's a story as well that goes that since she was the first woman to use this telescope, when she went to the restroom, there was only a male's restroom, so she taped a little skirt onto the restroom door so that she would be able to use it. And now there's actually an observatory being built in Chile that's supposed to start operating in 2022. It was originally called the Large Synoptic Survey Telescope, but now it has been changed to the Vera C. Rubin Observatory. And according to the National Science Foundation, this is the first American observatory to be named after a woman. Which is really awesome to be, since she is now being given the credit for her discovery. And so the last woman astronomer that I wanted to focus on, I had to, since we are at UCLA, is Dr. Andrea Ghez. She is currently a professor in the department working with the Galactic Center. So she won half of the Nobel Prize in Physics in 2020 and shares it with someone else, with Hensel, I believe. She shares, I will edit that in the comment section, apologies about that, but she shares it with half. I'm just so excited that Andrea won it. So she shares half of it for the discovery of the supermassive compact object in the center of our galaxy. So she found evidence for the supermassive black hole in our galaxy by looking at the orbits of stars nearby over the course of decades. And she is the fourth woman to win the Nobel Prize in Physics, and the first to win the first woman astronomer to win the Nobel Prize in Physics. So pretty cool stuff. And these are just that list of women, just the ones I went into detail. They are not all the women astronomers and discoveries that have been made. They were just the ones I decided to focus on. If you know any other women, please feel free to write that in the chat if I missed any. I'd also like to learn more about them. Maria Michel, I've heard of her. She's known as the first woman astronomer, and I believe she discovered a comet. But and also add in the comments so we can learn about more women astronomers. Here are a list of a few more. Paris Pismis, she was one of the first women to attend university in Turkey, and she was the first professional astronomer in Mexico, woman or man. She was the first ever. She studied galactic kinematics, globular clusters, galactic structure. And then there's Ruby Payne Scott. She's considered to be the first woman radio astronomer. Margaret Burbridge, she pioneered the modern studies of galaxies and quasars. Then there's Sandra Moore Faber. She's co-discoverer of the Faber-Jackson relationship, which relates the velocity dispersion, which is the random motion of stars in a galaxy, to the galaxy's brightness. And she was also instrumental in designing the Keck telescopes. And then the Wendy Friedman, she's a leader in measuring the expansion rate of the universe. And Gabriela Gonzalez, leader in detecting gravitational waves. Nancy G. Roman, she led the development of space telescopes. Jill Tarter, she's leader in SETI, or the search for extraterrestrial intelligent life. And then Sally Ride, she was the first American woman in space, but her training was actually in astrophysics. So, as I mentioned, please feel free to add more to the chat. It seems like Maria Michel founded the astronomy department of ISAR in the 1860s. Really cool. There was a bunch more that I did find before the 1900s. I just decided to focus on like this aspect. It's really cool stuff, and I kind of wanted to end this portion of the presentation with this message, just to any other like women astronomers like myself that are in their starting their early career, or like any little girls out there that think space is really awesome and might want to do astronomy in the future. This is a quote from Diana Buquin, who is the head librarian of the Center for Astrophysics. So she's leading that project I mentioned about preserving those glass plates from the Harvard Women computers. So this is her quote. She said, "Women have been there the whole time. They're still doing really important work today. This is one big continuum." So just a message I said to any other women astronomers out there starting their career, girls interested in the field. So now I will be moving on to the planetarium show. And this is just a quick shameless plug in which I wanted to ask if you all want to follow me on Twitter. I am trying to become more involved in the astronomy, science, communication community, so it'd be very awesome. But I will go ahead and switch over now to the planetarium show. So as I mentioned before, the planetarium show typically is at UCLA campus. A planetarium is, there's one like at Griffith Observatory if you've ever been. There's different observatories that have planetarium. They're very useful because they like let you see the night sky without all the light pollution. But today I'll be using Stellarium, which is a free computer software in which you can download for your computer. There's also an app for your phone. However, it is not free. It is $9.99. I looked into it last night and was hoping that maybe I can ask everyone to follow along, teach you all, but I didn't buy it. But I've heard read all the reviews. They seem like it's a really good app if you're interested. But if not, you can download the computer version for free. And right now I have it set up to 7:40. That is, it's about right now in present real time in LA. And this app, if you've used it before, has a lot of different settings, and we can see how it looks with the light pollution in LA. Let me go ahead and fast forward it just a bit so it can get a bit more darker since the sun is still setting. Okay. So let's do that. So you can see right now I have it on the setting where it represents the actual light pollution in LA. And let me see, sorry. So this is the current light pollution, as I mentioned, and it's pretty bright just because all the lights in the city. I'm going ahead and remove that now so it looks a bit darker. Let me also change this down to 1. I tried setting it to 0 earlier, but it wasn't letting me, so I guess I will leave it there. So just wanted to talk about some cool stuff that you can find in the sky right now and throughout April. Let me take this off really quick. I will start off by telling you all my favorite constellation in the sky, Orion, which mainly is just because it's the only one I can find on my own without a star map at night. So the way you can find it is looking for Orion's belt right there, those 3 stars, and right up above right there you can see Betelgeuse. So the way I do it is I look up for an orange star and then right below it the 3, and then I'm like, oh hey, there's Orion. But now I'll go ahead and cheat and have those labeled. You can see that's the constellation right there. It looks like he's like shooting an arrow. Okay, the next thing I wanted to show you all is the Pleiades, also known as the 7 Sisters, which you can see with your binoculars actually, but for that one I'm going to need to cheat because I don't and have the settings on Stellarium, so where it actually labels it. So you can see here. The way you would find it though is that you typically want to look for from Orion, it's really close by. So first you look for Orion right there, right? And then there's a star off to the side. So you would look for Betelgeuse, and then off to the side right there is Aldebaran, and right above is right next to it is Pleiades. So you'd want to look for Taurus, Orion, and then over to the side is the Pleiades star cluster. It's in a star cluster, and it's known as the Seven Sisters because there is seven of them right here in this area. Um, it was actually, fun fact, it was used to be used as a test for eyesight back before in older times. It was said that you would have they would look at the sky, and if you saw six, you were like considered normal. If you saw all seven, then you had really good eyesight, and they were typically chosen to be like warriors and anything else of that nature. So if you go out at the night sky right now around this time, today or tomorrow, I'd recommend using binoculars. With binoculars, I read everywhere that they look really pretty. So that's a really fun thing you can check in the sky and maybe try to play that game if you can see six or seven. I definitely would not be able to see seven, maybe five. But yeah, that's one of those. And then the other fun cluster is called the double cluster. And for that one, you want to look northwest for the constellation Cassiopeia. So first, how you said, we looked at Orion, which is you find the bright orange star, and then those three in the belt. Then you could look for, as I mentioned, we were looking for the Pleiades, so you'd look over for Aldebaran, which is in Taurus constellation, and then slightly over. Then to find the double cluster in Cassiopeia, you'd want to look northwest, so you'd want to end up moving northwest. And Cassiopeia, you can tell that constellation because it looks like this W right here. I'll go ahead and put this line right there. Although when you're looking at the night sky, it'd probably be useful to have some kind of star map because you won't see the W right there. So once you find the constellation Cassiopeia at what's like the furthermost left, the left point, if you look directly under, you will find the double cluster. So this is like another star cluster that if you grab binoculars at night will look pretty awesome, and you'll see just a whole bunch of stars in that area. Would definitely recommend. And that is visible right now around like 8 p.m. As you can see right here, if I were to fast forward this, because this is another cool thing about Stellarium on your computer, you can pick any time, any date, but you can see that the double cluster will start to go lower in the sky, and it starts to set around, right now it's saying it's 11 p.m. So around 11 p.m. it's getting a lot closer to the horizon. So you can see the double cluster for the first few hours in the night. And now just wanted to talk about a few other cool things that are happening this month. One of them is the Lyrid, I believe it's called Lyrid meteor shower. That's going to happen this month, April 16th to April 30th. It peaks on the 21st and 22nd, which is Wednesday and Thursday, in about like 3 weeks, I believe. Unfortunately, the moon will be pretty bright. I believe it's about 68% full, I read, but it will set at 1 a.m. So if you're a night owl and you want to see it, let me go ahead and fast forward to that time, or I don't need to fast forward, I can go to date time window. So let's go to April 20, that's not April 21st and 22nd is when I said it would peak. So if you were to go to that date, let's try to see the meteor shower here. It would have to be at 1 a.m. So perfect. We are all right. No, I said at 1 a.m. So we're actually at 11 p.m. So let me fast forward a bit more. And that is, okay, we're now at 1:55. Okay, so to look for the Lyrid meteor shower during that time, again, you want to go after 1 a.m. And let me also take, you want to look up and look for Vega first. Let me see. Okay, look for Vega. And once you find Vega, and it's in the Lyra constellation, as you see right there, and you're just going to want to look there. And it's during this peak, it's only about like estimated like 15, 20 like meteors per hour. So earlier I was testing this out, and at this time, and occasionally I would see something like fly, like kind of like go by as a meteor. I'll keep it on and see if we all can see them. But again, it's only 15 per hour. Um, sorry, I got a notification from the live stream. Okay, so it doesn't seem like I am seeing anything right now. Let me fast forward it just slightly, or make it go a little bit faster in time to see if we see any. Okay, so it seems like there's nothing that's appearing right now. Don't know if I'm being a little impatient because I'm live on YouTube. But earlier I did, and if you have the app at home, you could definitely take some time and check this out. Otherwise, if you're a night owl, as I mentioned, on the 21st of April and 22nd of April, the Lyrid meteor shower will be peaking, and you'll want to look for Vega in the sky. It's located in the east sky. Just look up east after 1 a.m. And that's Pacific time. So if you're on the East Coast, you'd want to do that. It'd be at 4 a.m. So I guess if you're an early bird on the East Coast, you can also watch this meteor shower. Okay, and then one last thing also happening that's very cool, happening in the month of April, or we'll probably at least make some of like news articles if you're into astronomy, will be that on the 26th there's a full super pink moon. Bummer, it's not actually pink. Pink is my favorite color. It's not actually pink if I go to the 26th. I tried this earlier. All it really means, the terminology has to do with its like location in this orbit, and it just appears a lot brighter essentially, but it's still the same color. And as you can see, now I'm on the 26th. This will be the night of the full super pink moon. It's very bright, not pink, still it's normal color, as I mentioned. So I will go ahead and can see the Milky Way. Oh, and also, since I just saw a comment about the Milky Way, I did want to mention it is now April is when it starts to like rise. It's slightly bright on like the horizon in April, but it's a better view the more south, like the more south you are, and it rises after midnight. It'll be later in mid-June where it will be higher in the sky and more visible, and particularly very, very visible in July. So I'm excited to look out for that. If you haven't seen the Milky Way before, I definitely would recommend trying to check it out this summer. Any dark sky, like a national park, you can definitely see it. And that also reminds me that next week, the 5th, starting the 5th, is International Dark Skies Night. Don't know. I guess you can go celebrate at a national park. I was trying to read up more on about it, but I just thought that'd be a fun fact to mention. Okay, that is all I have for you today. I hope you all learned a lot about some of these cool women. And as I mentioned earlier, as I mentioned earlier with that quote here, I said women have been a part of astronomy this whole time, and they've done important things like help us determine distances from other stars, help us classify stars, help us figure out temperature of the stars through that classification system. They helped us realize that the universe is mainly made of hydrogen and helium, which was not the thought before. They discovered pulsars. There's just so much that women have done, and happy Women's History Month, and I hope you all enjoyed the show. Feel free to leave any comments, how I said, in the actual comment sections once this YouTube video is posted, and let us know about any other women astronomers you know in your life and in history. Have